Hey guys, in this video we're going to start by writing some code and understanding how to create variables of type char, and then I'm going to go in depth discussing how text is represented in our code behind the scenes using Unicodes. So let's get started. Okay guys, so I want you to start by opening IntelliJ, creating a project and a class called characters, create the main method. Now I want you to write char letter is equal to a. You can only use single quotations around a character. You cannot use double quotations. This will give a compilation error because double quotations are used with strings. So it's telling you here that you are providing it with a string even though the required type is a char. Now I want to show you something. Let's print the letter. And I also want you to print the letter typecasted into int. So let's go ahead and run this. Okay, so we get an A, which is the letter, and we get 97, which is the letter typecasted into int. Let's go ahead and write int A is equal to letter. This is kind of what we did down here. So when we typecasted letter into int, we kind of did this, okay? So if you just print the A now, you'll find out that this is equivalent to this. So here it is. But isn't it weird that we can initialize a variable, let's call it b, of type int, and still give it a character as a value? How does this not give an error? Okay, so I need you guys to search for a Unicode chart and open any link that appears. And let's take a look at this. Basically, a Unicode is a character set, which means that it's a system that assigns a unique number called a code point to every character, okay? So for instance, this character, which is the A, it has this Unicode code point, which is in hexadecimal notation. This is why it might look a bit weird. The 0x at the start just tells us that this is in hexadecimal notation. So how does this Unicode code point translate to the 97, which is the decimal number that we see when we printed the character A typecasted into int in our code? Let's head to the board in order to explain this. So just for your own information, in binary, we know that binary is in base 2, right? Because we have just two possible digits, 0 or 1. Now in hexadecimal, the base is 16 because we have 0 to 15, which is 0 to f. So 15 is represented by f in hexadecimal. So when we have a number in hexadecimal notation like 0061, which corresponded to the 97 decimal for character A, how do we get this 97 from this hexadecimal notation? It's really similar to how we did it in binary, okay? So in this case, this is the 0th position, this is the first position, this is the second position, and this is the third position, okay? So these are just the positions for the hexadecimal numbers. So how we compute them is really similar. We just write, instead of 2, we write 16 to the power of 0, which is the position here, times 1. And we add this to 16 to the power of 1 times 6. So calculating this would give us the 97. In the next video, we're going to take a look at our last primitive data type, which is the Boolean. So see you there.